Let u be a differentiable function of x and let a be greater than 0. This is a second video in our integration of inverse trig functions. Our integrals will have radicals for sine inverse, secant inverse. There will not be a square root for arctangent. However, there will be some constant squared and some function of x squared in all three of them. Pause if you need to write these down. We're going to integrate from 0 to 1/3 the function 3 over square root of 1 minus 9x squared. 1 is 1 squared. 9x squared is 3x quantity squared. Matching this with the sine inverse formula above, u is 3x, a is 1. Derivative of 3x is 3 dx. Note in our integral we have 3 dx. That can be replaced with du. Under the radical we have a squared minus u squared. Be careful that when you substitute, your integral limits have to be substituted also. 1/3 times 3 is 1. 0 times 3 is 0. This is the formula for sine inverse of u over a. Without substituting back into x's, we can integrate this as arc sine of u and plug in 1 and 0. Arc sine of 1 minus arc sine of 0 to be exact. Arc sine is the angle at which your y value is 1. On the unit circle, the angle where your y value is 1 is at pi over 2. So that's the value of sine inverse of 1. Sine inverse of 0 is the y coordinate 0, and you need the angle. Anytime you have inverse trig, you need the angle. So the angle where the sine value is 1 is pi over 2. The angle where the sine value is 0 is 0. And that gives us pi over 2. We're going to integrate from 0 to square root of 3 over 3, the function 1 over 1 plus 9x squared. This one doesn't have a radical, so that leads us to believe it's going to be a tan inverse. And in fact, it is. 1 we can write as 1 squared, 9x squared we can write as 3x squared. This fits our arctangent formula perfectly. Our a value is 1. Our u function is 3x. Its derivative is 3 dx. This fraction doesn't have a 3 dx, it's only dx, so when I divide by 3, I can change dx to 1/3 du. The rest of this falls right into place. That's a squared, that's u squared. Remember, when you switch variables, you have to filter the original integral limits through your substitution. Square root of 3 over 3 times 3 is square root of 3. 0, 3 times 0, that's 0. So we'll carry our 1/3 down. This formula is arctan of u. In fact, it's 1 over a arctan u over a, but because a is 1, we don't have to write all that out. Arctan of square root of 3 minus arctan of 0. Trig inverse functions are looking for angles. So what we're looking for is the angle where your tangent value is square root of 3. If you remember from trig, that occurs at the angle pi over 3. The angle at which your tangent is 0 is at angle 0. Pi over 3 minus 0, that's pi over 3 times a third is pi over 9. The integral from 0 to natural log 3 of e to the x over 1 plus e to the 2x. 1 is 1 squared. E to the 2x is e to the x quantity squared. U is e to the x. E to the x has the same derivative as itself. Our denominator is a squared plus u squared. The derivative of u was ex dx, so this numerator becomes du. Natural log of 3, e to the natural log of 3 is 3. The e and the ln are inverses, they cancel. 0, e to the 0 power is 1. This is our arctan formula. Arctan of 3 minus arctan of 1. Since these are not, well, let me rephrase that. Since arctangent of 3 is not marked on the unit circle, it doesn't have any friendly angles that we're used to seeing on the unit circle. Of course, it does have an angle. Now, arctangent of 1 is pi over 4, because at the angle pi over 4, you have a tangent value of 1. But in this problem, and also you'll find in your homework, you're asked to approximate to 3 decimal places. Be sure that you're in radian mode, because these numbers are not degrees. If you carefully type in arctangent of 3 minus arctangent of 1, you should get 0.464 rounded to 3 decimal places. The integral from 0 to pi over 2 of cosine x over 1 plus sine x. If this square wasn't here, we could integrate with natural log, because the derivative of the bottom would be the top. But because that square is there, we're not able to use natural log. 1 we can write as 1 squared. Sine squared x, that's the same thing as sine x quantity squared. A is 1. U is sine x. Its derivative is cosine x dx. Note that's your numerator, cosine x dx. So we can trade all that out for du. This is the formula for arctangent. Arctan of 1 minus arctan of 0. And let me explain this 1 and 0. Pi over 2, sine of pi over 2 is 1. And when we plug in 0, sine of 0 is 0. So that's why I changed those integral limits. Anytime you have a substitute, you got to be sure to filter through. Arctan of 1, the angle at which tangent is 1 is pi over 4. Arctan of 0, the angle at which tangent is 0, and that's a difference of pi over 4.